Hello everyone. So welcome to my YouTube channel. So welcome to the last video of Thermodynamics NCERT based. So after this we will upload the one video of Thermodynamics in which we will solve all the 22 questions of NCERT exercise, which is very important, guys. I don't know in your colleges or in your school whether the teacher are making you to solve the NCERT exercise problems or not, but understand, guys, that is literally very important. Even in your board examination you will get the lots of 70 to 80% of questions you will get from NCERT exercise, remaining 25-28% from the middle of the NCERT textbook, and then remaining 2 to 3 or 4% will be little bit higher order thinking skill questions. Okay, so yeah, after this thermodynamics we are going to start with the periodic classification, chapter number 3. Okay, that is easy and very interesting. That is the inorganic part. Okay, if you understand that chapter properly, then only the other in S block, P block, the another inorganic concept of class 11th will be get clear. If you not understand that third chapter, then inorganic part will be like moe. Okay, and then if you not understand the class 11th inorganic, the bhaiya class 12th inorganic, it will be like bouncer. You will just keep on ducking, it will be like bouncer. Okay, तो भैया खत्म हो जाएगा, गड़बड़ हो जाएगा भाई, गड़बड़. Okay, so let's start with enthalpy of atomization. So enthalpy means this gondogol bhaiya. The enthalpy of atomization, or we can say standard enthalpy of atomization, chalega bhaiya, all are same. Why here? See, the thing is, I will tell you, standard enthalpy of atomization means this. You can see the node. This node indicates that standard. Okay, standard enthalpy of atomization. So what I will write here standard enthalpy of atomization. See, whenever we will say standard, understand two important things. First thing is, whenever we will take the quantity, whenever we will take the quantity, we will take 1 mole of a substance, 1 mole of substance. So this is the standard quantity, first thing. And second thing is, under standard conditions. The standard condition means temperature will be at room temperature, which is 278 Kelvin. Okay, and then what I can say, and one more, 298 Kelvin. So room temperature is 298 Kelvin. Golti 298 Kelvin the standard temperature, and pressure is 1 atm, 1 atmospheric bar pressure. Okay, so that is the two things we have to keep understand whenever we talk about standard. First quantity is 1 mole of substance. Second is standard condition. Standard condition is what? Temperature is 298 Kelvin, room temperature. Second, pressure is 1 atm. Okay. Now enthalpy of atomization. So it is denoted like this. Guys, very important thing and very easy also. It refers to the enthalpy of atomization. It refers to the energy needed to convert 1 mole of substance. Why I'm saying 1 mole? Yes, 1 mole, because we are talking about standard. So bhaiya 1 mole, ho bhaiya, re oh pyare, joldi dekho re. It refers to the energy needed to convert 1 mole of substance from its standard state into atoms, in the gas phase. Means what we are going to do, we have to standard enthalpy of atomization means we will take the energy, energy needed to convert. What we will convert? Because see, whenever you will give the energy, something will get convert. Either the phase will get convert, or the bond will break into radicals, or anything will get convert. So energy needed to convert 1 mole, because standard we are talking about standard. So energy needed to convert what? Standard means 1 mole of substance. 1 mole of substance, भैया कहाँ से? 1 mole of substance from its standard state into atom. And atom means how we want the atom? Atom in the gas phase. gas phase. This is very important concept, enthalpy of atomization. And here in the examination, even in true false or even in the NEET and JEE exam, they will ask the assertion and reasoning question based upon this. Very important topic, by very important. So enthalpy of atomization, what we understand the energy needed to convert. What we will convert? We are talking about a standard, right? So energy needed to convert 1 mole of substance. 1 mole of substance, where 1 mole of substance from standard state to atom, standard state into atom. And atom in which phase? Gas phase, because atom can be solid phase, liquid phase, gas phase, right? So atom in gas phase. So what we will do, the energy needed to convert, what it will convert? Standard means 1 mole of substance from standard state into atoms. And how the atoms? In gaseous phase. Okay, meaning the atoms are no longer bonded to each other, right? We are breaking in, so that's why atoms are no longer bonded to each other. We've broken down. Okay, so units is kilojoule per mole. Guys, this is very important thing. What the maximum student do the mistake is, enthalpy of atomization is 2. See, what we understand, enthalpy of atomization means energy needed to break the, right? Energy needed to convert like 1 mole, right, from standard state into atom, from standard state into atom in gas phase. So what, see, from this sentence, I will write this sentence, meaning that atoms are no longer bonded to each other. Atoms are no longer bonded to each other, because we know atoms will bond, they will make the elements, molecules. Okay, atoms will bond, they will make the molecules. So if atoms are no longer bonded to each other, means atoms are broken, right? So broken. So what the maximum student do the mistake is, they will think that enthalpy of atomization means we have to require the energy to break the atoms, or you can say to separate the atoms from the molecules, It is not like that. Okay, maximum student, what they think that enthalpy of atomization means we have to form the atom, from where? From molecules. We will break the molecules and we will get into atoms. So that's why, meaning the atoms are no longer bonded to each other, means atoms are separate, because atoms will bond, it will make molecules. So that's why atoms are no longer bonded to each other, means energy required to make the atoms. So if we understand this energy required to make the atoms, means what the maximum student think, that we are using the energy required to break the bond of molecules into atoms. So it is called as bond dissociation enthalpy, right? Because bond dissociation enthalpy is what? The same, the energy required to break the bond, right? So here also what we are doing in enthalpy of atomization, we are taking the energy, we'll convert this standard state like molecules into atoms, we'll convert into atoms, but it is not the bond dissociation, it is not the only bond dissociation enthalpy. It is bond dissociation enthalpy, but it's not only the bond dissociation enthalpy. It depends. So let's see here. Enthalpy of atomization means we get to know energy needed to convert. What will convert? 1 mole of substance from standard state into atoms, because atomization into atoms. The energy needed to convert 1 mole of substance from its standard state into atoms, and atoms in gas phase. Okay, this is important. Atoms in gas phase means the atoms are no longer bonded to each other. Means they are not in the molecule form, they are in the separate atom form. So what we will do, basically we are breaking the molecules into the atom form. So maximum student think that, oh, we are breaking the molecules into the atom form, then is a bond dissociation enthalpy, a bond dissociation energy, the energy required to break the bond. Enthalpy of atomization depends. We'll not say only the enthalpy of atomization is equals to bond dissociation energy. Bhaiya, moe will happen bhai, moe. Are joldi now understand the concept, joldi are bhaiya. Now see here, if H2 molecules, hydrogen molecules, if we will hydrogen molecules in the gaseous form, if we'll convert into hydrogen atoms in the gaseous form, so what is happening here? The hydrogen molecules are break down into 2 hydrogen atoms, right? H2 molecules, hydrogen molecules break down into 2 hydrogen atoms. Okay, main thing is, that's a thing we should have to keep in our mind, that in enthalpy of atomization we are forming the atoms, that is true, we are forming the atom, but very important thing, that atom should be in gas phase. Arey bhaiya, if you'll keep the atoms in liquid phase and all, oh bhaiya godbad ho jayega, godbad. So atom should be in gas phase. Okay, so see here the molecules of H2 which is in the gas phase will break down into what? Jaldi jaldi, into hydrogen atoms in the gaseous phase. So what is happening here? Here we will see enthalpy of atomization is bond dissociation enthalpy, because the hydrogen molecules bond are breaking down into hydrogen atoms. H2 molecules, the hydrogen molecules bond is broken down into what? Hydrogen atoms. So here we will say the energy required to break the bond of the molecules. So this is called bond dissociation energy, the energy required to break the bond. So here what we are doing, here H2 molecules, the bond of the hydrogen molecules are broken down into hydrogen atoms, broken down into hydrogen atoms. So here in this case we will say enthalpy of atomization is equals to bond dissociation enthalpy or bond dissociation energy, where energy required to break the bond. Okay, the molecules, the bond of molecules will break down into atoms. Okay, now but if you'll see in this condition, sodium which is in the solid form will convert into sodium in the gaseous form. So we are forming the atom which is in the gaseous form. Yes, we are forming the atoms which is in the gaseous form. We are converting, right? We are converting the this into atom in gaseous form. So here guys, what we are doing, we are changing the phase from solid to gas. Means here the enthalpy of atomization is enthalpy of sublimation, because what is the process? We will say that if we are going to convert the phase solid to gas means क्या भैया, जल्दी बोलो रे भैया. Yes sir, that is called as enthalpy of sublimation. So understand one thing, enthalpy of atomization is not only the thing. See, enthalpy of atomization means we know energy required to get the atoms, and atom should be in, jaldi bolo, which phase? Gas phase. Yes. So enthalpy of atomization means what? Enthalpy means what? Heat energy required to form the atoms, and atoms should be in gaseous phase. Okay, this is enthalpy of atomization. But in enthalpy of atomization we know we have to break the bond. So bhaiya please, enthalpy of atomization is not only the bond dissociation energy, because in enthalpy of atomization we'll take the molecules and we'll break the bond of the molecules and we'll keep the atoms. So enthalpy of atomization here is not only equals to bond dissociation enthalpy, because here you can see we are converting the 1 mole of sodium atom into 1 mole of sodium only, but we are converting from solid phase to gas phase. If you are converting the solid phase to gas phase, what we will say? Enthalpy of sublimation. So this process we are getting both enthalpy of atomization different. So that's why I said enthalpy of atomization depends. What will happen? Enthalpy of atomization depends. Understand? Yes sir. Here what we did guys, here hydrogen molecules, see phase are same, gas to gas, so we are not changing the phase. If you are not changing the phase, तो phase तो भैया कुछ नहीं होगा. Just we will see that hydrogen H2 molecules are broken down into hydrogen atoms. So we had broken the bond. So if you have broken the bond, to bond dissociation enthalpy. Okay, what the phase is same, gas phase. But here we will see that we are in the atom, we have only atom, so we are not going to change. Sodium atom will remain as sodium atom will not change, but here we will change the phase, because we want the atom in gas phase. We will change the phase. If we are changing the phase means which to which? Solid to gas. So that is called as enthalpy of sublimation. Okay, yes sir. So what you have to do guys, you have to write this enthalpy of standard enthalpy of atomization definition, and after definition you have to write this all till here. Okay, If you want to write this value, you can write. If you don't want, don't write, because this value is no need of this value. Just this is the conversion is important. Okay, understand? Yes, sir. Now after that we will see the next we will see the spontaneous process. See, we have a two types of process which you already know: spontaneous and non-spontaneous. Spontaneous means which the process will occur by itself, or just we have to apply some external things to start the process. After that the process will continue by itself. That is spontaneous process. Non-spontaneous process means it will not take place by itself. We have to keep on doing the things, so that's why the process will be keep on continuing. Okay, so spontaneous process means what? This is a thermodynamic process that happens on its own without the need of external source. So thermodynamics process is what? That happens on its own without the need of any external force, like melting of ice. You take out the ice, you keep the ice, that's it. It will melt automatically, right? No need of doing anything. Okay, see, but melting of ice here, what they said, a thermodynamics process that happens on its own without the need of any external source, like melting of ice, or initially, or or initially we need to trigger it through external source, but afterward it happens on its own, like burning of paper. So spontaneous process, what I said, spontaneous process means first thing is either the process will happen by its own, we should not have to do anything, the process will happen by its own. Just take the ice cube, keep the ice cube in the room at room temperature, nothing we are doing, just we kept the ice cube in at room temperature, automatically you will see the ice cube will melt. So what is this? Spontaneous process. The process is happening by its own. The process is happening by its own. That is what? By own, right? So this is what? This without any need, without the need of any external source. Okay. So spontaneous process means a thermodynamics process that happens on its own without the need of any external source. Without the need of any external source, it is happening by its own. We are not doing anything. Just we take out the ice cube and we kept the ice cube at room temperature. Now the melting of ice process will happen by its own without the need of any external source. That is the first condition. But second condition of spontaneous is or initially, just starting we need to trigger it through external source. That's it. Starting we should have to start the reaction. That's it. After that we will leave it. So what will happen afterwards? It happen on its own, like burning of paper. So burning of paper, what we will do, guys? Just we will take the bundle of paper, just starting external source I will apply. That's it. After that I will not do anything. After that I will leave it. So what we did, initially we triggered it by matchstick. And that matchstick is what? Our external source. So initially we triggered it with matchstick, and matchstick is our external source, and then afterwards we will leave it. Afterwards it happens on its own. So whole the paper will burn, right? So this is what? This is a spontaneous process. So spontaneous process, we know it's a two. First is either it will happen by its own without any need of external source. Second is just initially we have to trigger it by some external source. Afterward it will happen by its own. So this is called spontaneous process. Non-spontaneous, to bhaiya we should have to keep on doing, so that's why the process will continue. Okay, now spontaneous process can be reversible or as well as irreversible. The spontaneous process can be reversible or irreversible. So example like melting of ice at room temperature is reversible spontaneous process. So see, melting of ice, obviously I will take a bowl. Okay, in that bowl I will keep the ice cube. So what will happen? At room temperature that ice cube will melt into water. So that is the melting of ice. Then again I will take that same bowl and I will keep inside the freezer. So what will happen? That water will again convert into ice. So that's why melting of ice at room temperature is reversible spontaneous process. Okay, so melting of ice also we should not have to do. From ice will melt into water, from water again conversion of ice also we should not have to do, just we have to keep inside the fridge. That's it. It will take, okay, by its own it will complete. Now next is burning of paper. Burning of paper is irreversible. Obviously once you will burn the paper, right, starting what we will do, starting we will trigger it. We will trigger it by matchstick. Matchstick is external source. We'll trigger it by external source. That's done. Then the process will happen by its own. The paper will burn into ashes. Now from ashes we can't bring back the paper. So that's why burning of paper is irreversible but spontaneous process. Okay, so this one, standard enthalpy of atomization, you have to write all the notes, just don't write these values, no need of writing these values. Other than that you have to write the whole notes. Then spontaneous process, bhaiya, you have to write down this, the spontaneous process ka, and down till here, till here. And now I know that's, I hope you understand the process of the spontaneous process also, right? Yes sir. Now next is decrease in enthalpy. Okay, it is a one criteria of spontaneity. So decrease in enthalpy. Enthalpy means what will happen, guys? Decrease in heat energy. Decrease in heat energy, right? So see here, a chemical reaction, next topic is decrease in enthalpy, means decrease in heat energy. Okay, a criteria for spontaneity. This is the one criteria for spontaneity. Sometime in the option they will ask which of the following is a criteria for spontaneity. Decrease in enthalpy is a criteria for spontaneity. Okay, another criteria is also there, that is entropy. There are two criteria. Okay, first is decrease in enthalpy, second is what, jaldi bolo, entropy. But in examination this is the things you can expect in the MCQ. The criteria for spontaneity is decrease in enthalpy and entropy. Okay, so decrease in enthalpy means what will happen, guys? Jaldi bolo. Delta H value will decrease because enthalpy is what, whenever we will say enthalpy we will see H. So decrease in enthalpy means there is a change in the value. Change means delta H. So delta H, if it decrease, what will happen? Obviously negative, sir. Delta H will decrease. What will happen? Decrease in enthalpy, guys. Understand. Chalo, focus here, guys. Okay, chalo bhaiya, chalo. See what will happen, guys? Enthalpy, if I will take the enthalpy, that is H. If I will change in the enthalpy, either increase the enthalpy or decrease the enthalpy, what is happening? Change in the enthalpy. So change in the enthalpy means delta. So delta H. So delta H can be positive, delta H can be negative. So see, enthalpy, if system will absorb the heat, if system will absorb the heat, that is endothermic process, right? System is absorbing the heat. So endothermic process. So what will happen? Temperature increase. So increase in enthalpy means delta H is positive. Okay, if next condition is what? Next condition is system is releasing the heat. System is releasing the heat. If system is releasing the heat, what will happen? Exothermic process. So temperature will decrease. So temperature will decrease means decrease in enthalpy. Temperature will decrease means decrease in enthalpy. If temperature will decrease, so delta H is negative. Decrease in enthalpy means delta H is negative in exothermic process. In system release the heat, right? When system absorb the heat, that is endothermic process, temperature increases. If temperature is increased means what will happen? Increase in enthalpy. If increase in enthalpy means delta H is positive, right? Second is, if system will release the heat, that process is called exothermic. If system release the heat, what will happen? Temperature will decrease in exothermic. So there is a decrease in enthalpy. If temperature decrease in enthalpy, so delta H, the heat will also decrease. Decrease means negative. Okay, these two concepts you understand, very important. If you know, you know. If you don't know, please write. Okay, what you will write? You will write the thing is, if system absorb the heat, process is endothermic. In endothermic process, temperature increases. So there is increase in enthalpy. So delta H is positive because increase means positive, or delta H is greater than 0. That's also called positive. Okay, next point you will write, when system release the heat, it is exothermic. So temperature decreases. So if temperature will decrease, so that is decrease in enthalpy. So delta H is negative and delta H is less than 0. So now when delta H is 0 equals to 0, bhaiya, any delta, if you will talk any delta H change in enthalpy, delta G gives energy, delta S change in entropy, any change is 0 at when the any change will be 0. Joldi joldi bolo re bhaiya, when हाँ at equilibrium पे भैया everything is zero. Delta H, delta G, delta S, everything is zero at equilibrium. Okay, at equilibrium which process? Reversible process at equilibrium. Okay, now see, if I will not talk the equilibrium process, if process is not equilibrium, okay, if process is not equilibrium, then either it will be greater than 0, that is called as positive, or either it will be less than 0, which is negative. So if it is at equilibrium, every value delta H, delta G, delta S, everything is 0 at equilibrium. So at equilibrium the process is reversible process. Okay, second point is, if it is not at equilibrium, then delta G, delta H, delta S, anything, either it will be greater than 0, that is positive, or it will be less than 0, that is negative. So the process is what? Process is irreversible process. Okay, process is irreversible. Reversible is only at equilibrium, so it will be equals to 0. It's not equilibrium, process is irreversible, so that's why it's not equal to 0. Either it will be greater than 0 or either it will be less than 0, means positive or negative. Understand? Yes sir. Guys, see, these are the basic concept what I have already taught, and the same thing I am telling you. If you know this basic concept, well and good. If you don't know, please, what I am repeating now, mark the point and write down. Mark the point and write down. Okay, so that's why guys, here you can see irreversible process means what? Irreversible process means what? In a one direction, right? Irreversible process in a one direction, but reversible is a bi-direction. Okay, it will come and like forward and reverse direction, two direction. So see, decrease in enthalpy, a criteria for spontaneity. What the thing is, a chemical reaction is spontaneous in a given direction, either forward direction or backward direction. So a given chemical reaction is spontaneous in a given direction because decrease in energy has taken place. Because the decrease in energy has taken place, so that's why spontaneous in a given direction. Direction is fixed. What is the direction? Direction is from the system the heat is going out. From the system the heat is going out. So direction is fixed. From the system heat is going out. Direction is fixed. Why? Because decrease in energy. So direction is from system the heat will go out. If there is increase in energy, means direction is what? Direction is the heat will come to the system. Heat will come to the system, right? So that's why direction will be fixed, either it is decrease in energy or increase in energy. So a chemical reaction is spontaneous in a given direction. Why? Because decrease in energy has taken place. So decrease in energy has taken place means, in this case, the exothermic, I have explained you. Here we can say that there is a decrease in enthalpy, means delta H is negative, or in bracket we can write delta H is less than 0. Understand guys? Yes sir, I have explained you before also. Yes sir, तो इतना लिख लेंगे. After that guys, we will write this thing. Okay, wait. हाँ, okay, understand till here? Yes sir. So what will happen, why the given direction, and the thing is very important. I have explained you this thing. You have to guys keep in your mind. If you want, if you know guys, you know, that's it, very good, no need of doing anything. It's like a revision for you. If you don't know, then please write it. Okay, anything delta G, delta H, delta S, anything is equals to 0 at equilibrium. At equilibrium bhaiya, everything is 0. Okay, now if it is not equilibrium, so not equilibrium means what will happen? See, at equilibrium means process is what? At equilibrium bhaiya, process is, it will follow two directions. What it will do? It will follow two directions. it will follow two directions. Two direction means it is a reversible reaction. It is a reversible reaction. Okay, two direction means forward and backward, means reactant to product, product to reactant. If it is not at equilibrium, not at equilibrium means all these things we have a two condition. Either it is greater than 0 means either it is positive, or it is less than 0 means negative. So this is what, this is not a two direction, this is one direction. One direction, either it will go from reactant to product or product to reactant, means one direction. Okay, either it will come to the system or it will go out from the system, endothermic or exothermic. Okay, yes sir. And this is irreversible, irreversible. This is a very important concept. Okay, next guys, next we will give the arrow and we'll write about entropy. This is entropy, entropy. Entropy is denoted by S. Entropy is denoted by S. Now guys, see, very important thing, I will talk about entropy and delta S. Entropy and delta S. Okay, so understand here, there are two things, entropy that is S, and delta S means change in entropy. Okay, now understand guys, बहुत important है, very important है. This thing, wait, wait, कहीं पास लिखा हुआ है भाई, wait, I will show you, I will tell you. Yeah, okay. Now see, entropy, if I will talk about entropy, okay, entropy means what? See, entropy is a measure of the degree of randomness or disorder in the system. So entropy means we'll take any system, and if in the system we will see the particles are in randomness or disordered. Okay, like they are moving very fast. Okay, like suppose no teacher in the class, what you will do, you all are in a randomness and disordered manner. You will be running here, there, you will be going to that friend place, you will be enjoying, yeah, la 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 la, right? You will play the DJ wale babu mera gana chala do, DJ wale mera gana tu chala de, right? Zara volume to badha de. So what will happen, you will be in disorder, dinka chika dinka chika dinka chika. So that is called entropy. Okay, when you are in randomness, right, disordered, okay, you will be not in order, you will be running here, there, maar peet bhaiya, here, there, gorda uda doge bhaiya. That is called entropy. When the particles, you can see the gas particles, gas particle entropy is very high, because in gas the particles are high in the motion, highly randomness, disordered. So in gas the entropy is highest. Okay, so entropy means randomness. In solid you will see that all the particles are closely packed and with a strong force of attraction, so they cannot able to move freely, they will move very less, or there is a no movement. So entropy means randomness is what, nothing randomness, no disorder, everything is in a proper order. Understand the entropy? Yes sir. If you see the particles in the randomness, that is called entropy. So entropy for solid is very less than entropy for liquid, and then entropy for gas. Okay, so entropy for gas is very high, please write on this also. Okay, so okay, you have written this enthalpy of atomization, भैया पूरा ऐसे करके लिखना है इसको. Then spontaneous process you have to write full, then the spontaneous process, this all things you have to write. Then decrease in enthalpy, a criteria for spontaneity you have to write till here. Okay, and this also you have to write. And guys, this thing, in decrease in enthalpy, a criteria for spontaneity you have to write till here, with this delta H is less than 0. And this, if you know this concept, so fine, otherwise please write it. If you know, if you can able to understand, that's fine, no issues. If you think that no, you can able to forget this, so please write down. Okay, and you know, very important thing, when we will take the temperature, I have explained you, right? When the temperature will be, if system will take the temperature, that is endothermic temperature, sorry, if the system will take the heat, if system will absorb the heat, that is called endothermic. Endothermic means temperature will increase. I have explained that too, right? If you know that too also, it's fine. Otherwise you can write. I have dictated you before also, so you can write. Okay, after that you have to write the definition of just entropy till here and understand. After writing this entropy definition, write down this, write down this. So what is entropy for solid? Okay, entropy for gas is very high and entropy of solid is very less. Okay, so gas we know, because in the gas the particles are highly in the disorder or randomness motion, so entropy is very high. Okay, now we will see here, guys, we have to understand this S and delta S, understand this thing. Now see, if I will talk about entropy and if I will talk about change in entropy, okay, after entropy definition, write down this, that's it, khalas. Now understand, no need of writing anything, no need of writing anything. Okay, understand this, no need of writing anything. Now guys, if I will talk about entropy and change in entropy, okay, now see here, if I will increase the temperature, so based upon temperature, we will see the based upon temperature, based upon temperature. Okay, now guys, entropy, if I will increase the temperature, what will happen? Solid will convert into liquid, liquid will convert into gas. So what will happen if I will increase the temperature? Randomness will increase, right? If I will increase the temperature, randomness will increase. So after this what we will write? After this we will write this point, after this we will write that point. If we will increase the temperature, entropy will also increase. Just I am talking about entropy, I am not talking about change in entropy. Okay, now we know that guys, if you will increase the temperature, what will happen? Randomness or disorder will increase, right? Because from solid to liquid, right? From solid to liquid means what will happen? If teacher will go, what you will do? You will start become random. So if teacher is there, guys, you all are quiet, right? If teacher is there, you all are quiet. As the teacher will move, you will start. So what is happening? Yeah. So what is happening? Randomness. So now guys, see, I will tell you the two things. Now this, understand this thing. This is the class where temperature is normal. This is the class where temperature is normal. So if the temperature is, don't write anything, understand, if the temperature is normal, what you all will be sitting aram se, you all will be sitting easily, you all are sitting in the easy place, so you all are normal, right? If temperature is normal, you all are normal, you all will be sitting in your place. Okay, now guys, delta S means already here entropy is going on. Means already you are in the disordered. Means you are already running here, there, blam, blame, everything. You are throwing the decks, you are playing the DJ, you are enjoying, you are throwing the bags, lunchbox. You are already in the disordered. So what will happen if I will increase the temperature? So already you are in disorder. If I will increase the temperature, what will happen? You will be in disorder only. Again you will become disorder more. So what will happen? See, understand one thing. Already you are in disordered manner. You are running here, there and all. Okay, if I will increase the temperature also, what will happen? You are already in the disordered manner. If I will increase the temperature, your disorder will increase. But we cannot able to measure the large increment. Why? Because suppose there is a party hall. Okay, already DJ is playing on, already the high volume DJ is playing, and you all are dancing on the DJ. Ghumar hare ghumra. Okay, so you all are dancing in DJ. 4 baj gaye lekin paade ab bhi baki hai. So what is happening? DJ is full. You all are dancing. Oh bhaiya nacho. You all are dancing. Nacho. You all are dancing. So what is happening? You all are in the entropy. Okay. So suppose volume is 90. You all are in entropy. Randomness. So from 90 I will increase the volume to 120. I am increasing the temperature. volume think as a temperature, volume of the DJ think as a temperature. Okay, suppose temperature is 90, as I am saying that volume is 90, right? Volume level is 90. Suppose temperature is 90 degrees Celsius. You all are dinka chika, you all are dancing. Now what I will do, from 90 I will increase the temperature to 120. What will happen? You all are in randomness, so what will happen? Your level will be like that only, a little bit increase in the level, because you are all in your full mood. You have taken, sorry, you have given all your energy in the dancing. If I will from volume 90 I will increase to 120, what will happen? You all will be like fast. Yes, how much increment? Little increment of the energy, little increment of the randomness, little increment, right? So what is this? Delta S bhaiya, with temperature increase, delta S we will say remains same. Delta S will not depend. Delta S, nothing will happen to the delta S. There is change will happen, but very less change. As I have given the example, you all at the 90 volume of DJ is 90. You all are in the party mode. You all are dancing. From 90 I will make the DJ volume to 120. What is happening? Nothing. You all are already in the mood of dancing. Little bit you will increase your energy. So what is happening? Already you are in randomness. If I will increase the temperature more, what will happen? Little randomness will increase, because already you are in high randomness. If I will increase the little temperature, your randomness will increase by little. So what is happening? There is a change in randomness, but very negligible change. But suppose in this condition, you all are sitting in a party hall, aram se. Suddenly I bring the DJ and I will play the DJ. Before you all was normal. Now I played the DJ. You all start dancing. So what is happening? Here the randomness will increase. Here the disordered will increase, and we can observe the disordered randomness. The observation is huge. So that's why S means entropy will change when the temperature will increase. Entropy will increase when the temperature will increase. But change in entropy does not change much with the temperature. So that's why we will say that it does not depend much on the temperature. Okay, understand? So what is happening? Suppose you all are sitting around. I increase the temperature. Suddenly, oh my God, temperature increase. Bhago. Right? Suppose you are the people of Kashmir. You stay in like cold place. Suddenly I will bring to Rajasthan. You are, oh my God. Arey bhaiya, kya ho gaya? Arey bhago. So you are in Kashmir. So you are aram se. Suddenly I will increase the temperature, so we can see the order. You can observe the disorderedness. You will be like, arey bhai, where I came to Rajasthan. Arey bhai, I will die. Right? But suppose you are already in the Rajasthan staying with 45 degrees Celsius. You are already in Rajasthan staying with 45 degrees Celsius. You are already, arey bhai, kya ho jayega? From 45 day, next day it became 48 degree or 50 degree. What will happen? You already staying there. So randomness will be little more randomness. So that's why change of entropy is very negligible. Understand? So guys, exam में पूछता है भैया, entropy will increase with increase in temperature, but delta means change in entropy bhaiya, no effect with the increase of temperature, because already you are in entropy at 45 degrees Celsius. You are in Rajasthan. You are surviving that much heat. 45 to 50 degrees Celsius. What will happen? Randomness will increase, but very less, negligible. Okay, so this point you can write. Entropy increases if temperature increases, but if temperature increases, change in entropy will not affect. There will be increase, but very less increase, negligible. Okay, I hope you understand this. Okay, so after entropy definition, you have to write this, and then you have to write this. Okay, after that we'll start with this point. See what they said. If the structure of the product is very much disordered than that of reactant, there will be a resulting increase in entropy. Obviously guys, obviously. So bhaiya, see, this is reactant, this is product. If product is very much disordered means what is happening? from reactant we are going to product. Product is very much disordered, means entropy is what? There is an increase in entropy. Okay. Now ulta. If suppose reactant will be what? Reactant will be more disordered. Reactant will be more disordered, means we are going in backward condition. Backward condition means delta S is negative, means decrease. Okay. So understand one more thing, guys. If product is more disordered means from reactant to product we are going reactant to product, we are moving forward. If product is more disordered means we are moving from reactant to product, means we are moving forward means increase in entropy. Means what? Positive, greater than 0, right? If suppose reactant is more disordered means we are going backward from product to reactant, if reactant is more disordered we are going backward from product to reactant. So in this condition what is happening? We are going in reversible direction. The reversible direction means entropy will decrease means entropy will be negative, means less than 0. Understand? Yes sir. That's what that they said. If structure of the product is disordered, then what will happen? Then resultant increase in entropy. ठीक है भाई, समझ में आया? If product is more disordered means we are going from reactant to product, forward direction means entropy will increase, so positive or greater than 0, anything we can say, right? If reactant is more disordered means we are going from product to reactant, means backward direction means resultant decrease in entropy, right? There is a decrease in entropy means negative means less than 0, right? This is the concept you have to keep in your mind. If you know, if you can, तो भैया ठीक है, otherwise the same point you can make note and you can write in your own words. Okay, after this you have to write from here to here. Okay. Okay. And guys, we know wherever I will use the delta, like delta G, delta H, delta S, is all depends upon the state function, right? Initial state and final state we already studied. Like suppose if I will write H, G, S and delta H, delta G, delta S, so wherever I will write the delta for anything, delta H, delta G, delta S, delta U, any delta if I will write, so delta is what? Delta is a state function. Means it will depends only on the initial value and final value. Already we know this, right? Yes sir. Okay, so next thing is we will see this. चलो भैया ये important है, देख लो भैया. After that we'll write this point from here. If heat is added to a system, suppose heat is added to a system means system is absorbing the heat. So heat is added to the system means system is absorbing the heat, endothermic process. So what will happen? See, if heat is added to the system containing gas, okay, heat is added to the system which is containing gas at constant temperature, what will happen? It will completely be used in expansion of gas. Obviously guys, see there, if heat is added to the system means endothermic process. Means what will happen? The randomness will increase. Means what will happen? The particles of the gas will hit to the piston and the piston will move up. Before also we have studied the piston will move up. So what will happen? There will be expansion of the gas, right? So that's why they said the same thing. If heat is added to a system which is containing gas at constant temperature, it will completely be used in expansion of gas, right? Because heat will be there. What will happen? The particles will gas start moving randomly. So they will start hitting the container, they will start hitting each other, they will start hitting the piston. So what will happen? The piston will move up. So that's what expansion of gas. We already studied this concept before. So what will happen? Their expansion of gas means volume increase and now more space is available for gas particles to occupy it. Okay, occupy it means more disordered or chaos, right? Easy thing, correct? Volume will increase means what will happen? Now there's a more space for the gas particles to occupy, means there's a more randomness, disorder, right? More space means more particles will move highly, correct? Less space means what will happen? The particles will not get the more space to move, so disorder will decrease. So from here what we understand, if volume decrease, disordered decrease. Write down, if volume decrease means compression process. In compression process what will happen? Disordered will decrease, because volume will decrease, compression will happen, so there is a less space for the disordered. So now next you will write is, if volume increase, expansion process, right? Volume increase, expansion process, so disordered will increase, because we will get the more space for the disordered, for more space for the randomness, so disordered increase. Okay, after writing till here, now we'll see this thing. Delta S is directly proportional to the heat transferred to or from the system reversibly. Okay, so just keep in your mind, delta S, what delta S is directly proportional to heat transfer either to the system or from the system reversibly, means what? Heat transfer to the system, heat transfer to the system or heat transfer from the system. So the process is reversible. The process can be both, either it transferred to the system or it transferred from the system, positive or negative. So endothermic or exothermic. So that's why they said delta S is directly proportional to heat transfer to the system or from the system reversibly, for both process. Okay, then we will write down this. Temperature भैया, तो temperature, see, we know about temperature is what? Measure of average kinetic energy, right? As will increase the temperature, what will happen? Kinetic energy will increase, correct? So temperature is what? Measure of average kinetic energy of particles of a system. So guys, see, same thing I explained you here. So if same amount of heat is same amount of heat is added to two system A and system B, where temperature of B is greater than A, then more disorder will be created in the system with lower temperature, that is A. The same thing I explained you here, guys. This thing, here the temperature is lower, so what will happen? If I will increase the temperature, disordered I can see more. But here already the temperature is high, means you are already in disordered movement, you are already in the Rajasthan at higher temperature. So here if I will increase the temperature, so bhaiya, disordered you cannot able to find it, very negligible disorder. You are already in Rajasthan with 45 degrees Celsius. If I will increase the temperature to 50 degrees Celsius, disorder will be there, but very less disorder, so negligible. So that's why they said the disordered we will get where the temperature is low, because temperature is low means you are normal. Now suddenly if I will increase the temperature, you are disordered, I can see, I can observe your disordered. But already where the temperature is high, they are already in the disordered movement. So from there if I will increase the more temperature, disordered movement already there, so increase in disorderedness but very less. So delta S we cannot able to find it, means we can find but it will be very negligible. So that's why they say temperature is a measure of average kinetic energy of particle of a system. Is same amount of heat is added to two systems, system A and system B, where temperature of B is more than A. So B is more means already you are in Rajasthan, you are in randomness. From 45 if I will make the 50, if I will increase the temperature to 50, what will happen? I cannot able to measure the randomness, because already you are in randomness. So in randomness will increase very less. So that's why it is negligible. But if temperature is less, like you are in Kashmir, temperature is very less, suddenly I will bring you to the Rajasthan, then I can observe your disorderedness. So that's why what here, then more disorder will be created in system with lower temperature. You can observe the disorder. So that is in the system A. Understand? We will write on this all. Okay, then guys, this change in entropy, delta S is inversely proportional to temperature. Just now I explained you are already in the randomness, so bhaiya delta S is inversely proportional to temperature. You are already in randomness, already in Rajasthan with 45 degrees Celsius. If I will increase to 50, what will happen? Randomness will happen but very less. तो भैया टेम्परेचर पे कुछ नहीं होता है. बट यू आर सिटिंग आराम से लो टेम्परेचर इन कश्मीर, सडनली आई विल ब्रिंग टू राजस्थान हाई टेम्परेचर 50 डिग्री सेल्सियस, आई कैन सी योर randomness that you are running here there. Okay, so that is very important concept and I hope you understand this concept, right? Next point, entropy of a spontaneous process increases. See, entropy of a spontaneous process, spontaneous means the process which happens by its own. So entropy of a spontaneous process increases till when? Till when the entropy of a spontaneous process will increase? Arey bhaiya, arey oh pyare, we know if you are not in equilibrium, means either you will increase, means positive, means greater than 0, or you will decrease, means negative, less than 0 at equilibrium. Sorry, if not in equilibrium, then only either increase or decrease. Change will happen if you are not in equilibrium. So increase will be till when and decrease will be till when? Until and unless you will not reach to 0. Until and unless you will not reach to 0. Okay, means until unless you will not reach to equilibrium. So entropy or anything will increase till when? Till you will not reach to equilibrium. Means equilibrium means 0, everything will become 0, saturated. And decrease will be when? Decrease will be till you will reach to equilibrium, because at equilibrium everything will be 0, saturation. So very important. Entropy for a spontaneous process increase till when? It reaches maximum at equilibrium. Equilibrium means change in entropy is 0. Just I have said you this thing, guys. The same thing bhaiya, this thing. Okay, same thing. This is very important concept, very important concept. After that, guys, we'll write this. Entropy S is directly proportional to temperature, while change in entropy is inversely proportional to temperature. This also we will write. And this also things, guys, I had explained you. I explained you bhaiya, yahi wala, sorry, ye wala guys, ye wala. So entropy will depend upon temperature, but change in entropy delta S is inversely proportional to temperature. See here, entropy directly proportional to temperature. Haha, this concept is very important re bhaiya. Are oh pyare, joldi dekho re. Now guys, one more thing. Now don't write anything, write down till here. How I explained you write down till here. I hope till here the concept is clear, right? Till here your concept is crystal clear, sir. Now guys, in the examination they will ask this type of question. Is find out the entropy change. They will ask the question in the examination, find out the entropy change. अरे ओ प्यारे, देखो न रे भैया, एंट्रोपी चेंज मतलब डेल्टा एस रे. अरे ओ प्यारे, जल्दी देखो रे. फाइंड आउट द एंट्रोपी चेंज जहां वर्ड, वेयर एवर द वर्ड चेंज विल कम, आई विल ब्रिंग डेल्टा इन द केमिस्ट्री भैया. फाइंड आउट द एंट्रोपी चेंज आई विल राइट इट हियर. N2 gas plus 3H2 gas, it will give 2NH3 gas. Another one, PCl5 in gas, it will give PCl3 in gas plus Cl2 in gas. They asked the find out the entropy change. Entropy change means either it will be positive or either it will be negative. Positive means greater, negative means smaller. Let's see. Guys, very easy peasy things, understand. Find out the entropy change. So entropy change we will see from the, guys, number of moles. Entropy change we will see from number of moles. Bhaiya dekh lo bhaiya, entropy change we will see from number of moles. How you can see here? How many moles of N2 here? 1 mole, right? How many moles of N2? 1 mole. And here how many moles of H2? 3 mole. So 1 plus 3. On the reactant side we have 4 mole, but on product side we have 2 moles. Product side we have 2 moles, reactant side we have 4 moles. Means which is more? Bhaiya, reactant is more. Reactant is more. If reactant is more means, see here. अरे देखो रे भैया, अरे जल्दी जल्दी देखो रे, अरे बाबा गड़बड़ नहीं करना रे, अरे देख लो रे, देख लो रे, देख लो रे, प्रोडक्ट इज वेरी मोर. तो क्या होता था भैया? इट विल रिजल्ट इन इंक्रीज इन इंट्रोपी. हियर विच इज मोर? रिएक्टेंट इज मोर. अरे ओ भैया, रिएक्टेंट इज मोर मीन्स reactant is greater than product for the number of moles. Reactant is greater than product. Reactant is more. If reactant is more means delta S is negative or delta S is less than 0. Okay, find out the entropy change. Here entropy change is what? You can see in the reactant we have a 4 moles, in product we have a 2 moles, so reactant is greater than product, so delta S, the change is negative. Change is negative means there is a decrease in entropy. Decrease in entropy. Okay, yes sir. अब यहाँ देखो भाई, here you see guys, here we have a 1 mole of PCl5, so on reactant we have bari 1 mole there. Now in product we have 1 mole of PCl3 and भैया 1 mole of Cl2. 1 plus 1 2 mole. रे बाप रे. We will write here we have 1 mole of reactant and 2 mole of product, means here product is greater than reactant. Product is greater than the reactant means delta S is positive, or we'll say delta S is greater than 0. Means find out the entropy change means there is an increase in entropy. There is increase in entropy. Understand? Yes sir, I understand sir. This type of question they will ask in the examination. So entropy change means directly we will see on based upon the number of moles. Directly we will see based upon the number of moles. So which side the number of moles will be more? We have to just check it out. If reactant is greater than product, then reactant means we are going in backward. Reactant, so backward means delta S is negative, delta S is less than 0. Less than 0, less than 0. So there is decrease in enthalpy. Sorry, decrease in entropy. If product is more means we are going forward. Product is more means we are going forward. Means product is greater than reactant. Forward means delta S is positive. Means delta S is greater than 0. Means there is increase in entropy. Understand? Yes sir, yes sir, yes sir. 3 back full. Now next heading we will write second law of thermodynamics. अरे ओ भैया जल्दी जल्दी देखो रे. Second law of thermodynamics. Second law of thermodynamics. Second law of thermodynamics means, second law of thermodynamics guys, we will just write down the statement. Second law of thermodynamics means the total entropy of the universe, the total entropy of the universe, the total entropy of the universe will always, now we'll write on this. Okay, second law of thermodynamics means this, the total entropy of the universe will always increase, will always increase for a spontaneous process. ठीक है. This what the second law of thermodynamics says. What the second law of thermodynamics says, the total entropy of the universe will always increase for a spontaneous process. So here guys we'll write the condition delta S total means total entropy is, see either thing is either is greater than 0 or delta S means total entropy will be less than 0 or delta S the total entropy is equals to 0. Guys we know at equals to 0 means bhaiya it is at equilibrium. At equilibrium delta this is equal to 0. Now greater than 0 means see increase, greater than 0 means positive means increase, so it will happen only in the spontaneous. So we will write here, यहाँ लिख दो भैया. अरे ओ भैया देखो ना, डेल्टा एस इज ग्रेटर देन 0 मीन्स पॉजिटिव भी लिख सकते हैं और डेल्टा एस विल इंक्रीज. तो विच इन विच प्रोसेस? spontaneous process. Now delta s is less than 0 means negative means decrease मतलब भैया non spontaneous process non-spontaneous process. Non-spontaneous process. Okay, chalo bhaiya. I hope you understand till here, right? Yes, sir. We understand, sir. Now, guys, after this, we will write this only. This is very important. Now, we will talk about reversible isothermal process. Reversible isothermal process. Reversible isothermal process. So see, it is a reversible isothermal. Reversible means क्या होगा? जल्दी बोलो भाई. Reversible means equilibrium. Reversible means equilibrium. Right? Yes, sir. Reversible matlab, guys, reversible. It can reverse. You can go in forward direction. From forward you can come to backward. Right? So the equilibrium. Reversible isothermal process means equilibrium. Reversible matlab equilibrium. Reversible means equilibrium. Okay. At equilibrium, what will happen? Delta U 0. We know at equilibrium, bhaiya, sab cheez is 0. At equilibrium, what will happen? Everything is 0. So delta U is 0 at equilibrium. Then delta S total is 0 at equilibrium. Then at equilibrium, what will happen? At equilibrium, expansion will happen. At equilibrium, what will happen? Expansion. Okay. Wait a minute. Reversible. हाँ ठीक है. Reversible isothermal process at expansion. This is at expansion. Okay. They will say you the condition. Reversible isothermal process at expansion. Reversible isothermal process at expansion. So irreversible means it will be equilibrium. Delta U 0, delta S total 0, right? Now, guys, one thing which is very important you have to understand is the formula of delta S. Okay, formula of delta S is what? Formula of delta S of system. And then we will write down the formula of delta S of surroundings. Understand, very important thing, guys. Understand. This is in examination they will ask. Reversible isothermal process at expansion. Reversible isothermal process at expansion. So this is what? This is a equilibrium process. Because it is a reversible to equilibrium process. Means delta U is equals to 0. Delta S total is equals to 0. Okay. Now, guys, isothermal means what? Isothermal means we will write one more thing. Temperature is constant. Isothermal means we will write temperature is constant. Next we will write, guys, delta S for system and delta S for surrounding. So this is a condition for reversible isothermal process but at expansion. Reversible isothermal process but at expansion. Okay. So, guys, this formula we already know. So system का क्या हो जाएगा? Q, because we are talking about reversible, so I will write Q reversible by temperature. So, guys, if system is plus, right? System is plus. Why system is plus? Because it is expansion. The expansion means increasing. Increasing means randomness will increase. If volume will increase, what will get? We'll get the more space. More space means randomness will increase. So expansion means what will happen? Delta S will be plus for the system, because system is only expanding, right? System is expanding, surrounding will be compressing. So if system is plus, surrounding will be minus. Obviously we know if one is plus, one will be negative. If one is negative, other will be positive. So what is happening here? Expansion means system is expanding. If system is expanding means entropy of the system will increase. So increase means positive. So how it will increase? The heat and temperature. So heat, that is also will take reversible because it is reversible process. Heat for the reversible process divided by temperature. So this will become my surrounding means heat for reversible process divided by temperature. Just the sign will get changed from positive to negative. Okay. So this is a positive means it will become 2.303 nr log 1 minute. 2.303 nr log V2 by V1. V2 because expansion means what? Volume is changing. So log V2 by V1. Because see guys, here already we studied this formula. Okay, Q reversible, what is the formula for Q reversible? 2.303 nRT log reversible. Reversible means this expansion process, not the volume V2 by V1. So guys, see here, Q reversible divided by T. If I will do this, Q reversible is this divided by T. So T will get moe. So that's why Q reversible by T will get 2.303 nR log V2 by V1. We don't have T because T got cancelled. So if this is plus, this will become automatically minus. Okay. So minus 2.303 nR log will take the volume V2 by V1. This is the process for the expansion. Okay, delta S for the system will not be 0. Guys, see, understand, delta S for the system and delta S for the surrounding will not be 0. Total change will be 0. Guys, what will happen? Total change will be 0. What will be 0? Total change of entropy will be 0. Okay, system entropy and surrounding entropy will not be 0. System entropy is what? It is the expansion process. Guys, understand why I am writing this. You have to understand reversible isothermal process at expansion. They will say this condition. Okay, reversible isothermal process at expansion. So reversible means equilibrium. Isothermal means temperature is constant. Equilibrium means delta U, internal energy is 0. Total entropy change is 0. Not only the entropy of the system is 0, not the entropy of surrounding is 0. Total entropy change is 0. And भैया we know delta S का formula क्या होगा? System expansion means system is expanding. System is expanding means volume of the system is increasing. If volume will increase, what will happen? Yes, randomness will increase. So entropy will increase. So entropy for the system will be plus. If system entropy is plus, so obviously the entropy for the surrounding is negative. One plus, other negative. So we know this formula. Delta S is equal to Q reversible. Why I am writing? Because it is a reversible process. If it is irreversible, we'll write irreversible. Okay. So Q reversible by temperature. This formula will remain same. Q reversible by temperature. So Q reversible is this 2.303 nRT log V2 by V1. Because it expansion means volume is changing. So we'll take the V2 by V1, final volume by initial volume. So Q reversible is this by T means divided by T will get moe. So that's why the formula is 2.303 nR log V2 by V1. In the examination, so many times they had given the formula, which is the correct formula in MCQ. The student have ticked this one, 2.303 nRT log V2 by V1. Bhaiya, it's not nRT. Why? Because the formula is Q reversible by T. T will get cancelled. You will get 2.303 nR log V2 by V1. If this is plus, so bhaiya this is minus. That's it. Khalas. Formula will remain same, just the sign will get changed with plus and minus. Another thing we will write for irreversible. Reversible हो गया भैया. Next we will write for irreversible isothermal process. Irreversible isothermal process. भैया इसका ज्यादा, they will not ask this much more, but write down irreversible. Guys, irreversible isothermal process. Isothermal means what? We know temperature is constant. Temperature is constant. If it is irreversible means not equilibrium, not in equilibrium, or it will not satisfy the equilibrium condition. Okay, irreversible means delta S is not equals to 0. So what will happen then? Delta S should be greater than equal to 0 means delta S is positive. And delta U is, guys, see, delta U will be 0. Internal energy I am not going to change. So delta U will be 0. And delta S is not equal to 0 because it is not equilibrium. If not equal to 0 means delta S we will favor. So delta S is greater than 0. Why it is greater than 0? Greater than 0 means positive. The reason behind is it is irreversible. Irreversible means it is moving in one direction, that is forward. We will we will favor the forward direction, we will favor the forward direction. तो forward direction मतलब क्या होता है भैया, positive greater than 0, right? Yes sir. Now next we will see is about Gibbs energy. Next heading we will write is Gibbs energy, Gibbs energy and spontaneity. Okay, this is in sometime in the examination they will ask also in the 1 marks. Write the relationship between Gibbs energy and, see, you can say this Gibbs energy and spontaneity, or relationship between Gibbs energy and spontaneous. Spontaneity is nothing but spontaneity is nothing but spontaneous. Okay, means entropy. Spontaneity is nothing but entropy. So Gibbs energy and entropy, or see, this topic is Gibbs energy and entropy. Sometimes they will ask in the examination, write down the relationship between Gibbs energy and spontaneity, or they will say write the relationship between Gibbs energy and entropy, or one more thing. Okay, give the relationship between Gibbs energy, enthalpy, temperature and नहीं ऐसा हाँ, give the relationship between Gibbs energy, enthalpy and entropy at constant temperature, ठीक है. तो either they will say relationship between Gibbs energy and spontaneity, or they will say relationship between Gibbs energy and entropy, or Gibbs energy, relationship between Gibbs energy, enthalpy, entropy at constant temperature. The formula is this: delta G is equals to right, Gibbs energy means delta G is equals to enthalpy delta H minus constant temperature means T delta S. Okay, this is the relationship. Okay, and delta C, delta G, delta H, delta S, all delta is what? All delta is state function. State function means extensive property. Okay, so guys, see, this we get to know. This formula is for relationship between Gibbs energy and spontaneity, or relationship between Gibbs energy and entropy, or relationship between Gibbs energy, enthalpy and entropy at constant temperature. So temperature is just T. Okay, suppose if they will say relationship between Gibbs energy, enthalpy, entropy at okay, when temperature is not constant, when temperature is not constant, Bhaiya, now temperature, see, relationship between Gibbs energy, enthalpy and entropy, when temperature is not constant means all the 4 is not constant, all the 4 is changing. Are oh pyare, dekho re bhaiya, not constant means all 4 is changing. So delta H is equals to delta H minus delta TS, delta H minus delta TS, delta H minus delta TS. So here we will write the delta in the temperature also, delta TS. This is very rare they will ask, but they can ask. This is important for the numerical also, तो भैया फॉर्मूला दिमाग में कंठस्थ मुखस्थ भ्रनष्ट कर लेना रे भैया. नेक्स्ट पॉइंट इज again this delta G. If you are talking about delta G, so delta G we have a 3 value, either greater than 0 means positive, delta G we have a like less than 0 means negative, or delta G we have equals to 0. भैया equals to 0 मतलब equilibrium, equals to 0 when it will be at equilibrium. Greater than 0 means positive, less than 0 means negative. तो greater than 0, see, देखो भैया यहाँ पास देखो, delta S total greater than 0, it's for spontaneous. यहाँ पास change होता है, it's not the same. Delta G is greater than 0 means negative, it is for delta G is greater than 0 means positive, means it is for non-spontaneous process. If it is a non-spontaneous process, then delta G is greater than 0 means positive. If it is a spontaneous process, okay, if it is a spontaneous process means delta G is less than 0, that is negative. Okay, if delta G is 0 तो भैया इक्विलिब्रियम. ठीक है, यस सर, इक्विलिब्रियम सर. चलो भैया, चलो चलो, दिस इज अ वेरी इंपॉर्टेंट भैया न्यूमेरिकल के, दिस इज वेरी रेयर दे विल आस्क. ओके, आफ्टर दैट वी विल राइट डाउन, बहुत इंपॉर्टेंट गाइस, हाईली इंपॉर्टेंट, भारी 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 इंपॉर्टेंट. डेल्टा G equals delta H minus T delta S. See why, how I will show you. Right, this is very very important, very important. Delta H naught, sorry, this table is important guys, this table is important. Delta H naught, delta S naught, delta G naught, and then we have to write the here like what the process will happen, for which process. Okay, very important guys, very important. First one, delta H is negative, delta S is positive. Okay, delta H, delta S, delta H is negative, delta S is positive, so delta G is what? Delta G is also negative. So this process will, this condition will be, this will be, see, spontaneous reaction guys. See here, I will write the SR I will write for spontaneous reaction. Okay, and I will write NSR for non-spontaneous reaction. Okay, SR for spontaneous reaction, NSR for non-spontaneous reaction. So here space is this, so that's why. But you all don't write SR and NSR, you have to write the total. Okay, so see, in the examination they will say, if delta H is negative and delta S is positive, what is the value of delta G and what is the process? Okay, if delta G is negative, delta S is positive, sorry again guys, if delta H is positive, delta S is negative, so delta G is also negative, and the process is spontaneous reaction at all temperature, spontaneous reaction at all temperature. This is important guys, because here we have a 3 temperature. At all temperature means at low temperature also, at higher temperature, because we have a 3 temperature, at low temperature, at high temperature, at all temperature. All temperature means including both, at low also and at high also. Second is delta H, delta H is negative, delta S is also negative, so delta G is also negative. Okay, this is spontaneous reaction at low temperature, spontaneous reaction at low temperature. थर्ड वन में हम लोग लिखेंगे भैया, डेल्टा H is negative, delta S is also negative, so delta H is positive when it is a non-spontaneous reaction at high temperature, non-spontaneous reaction at high temperature. Okay, next fourth one is delta H is positive, delta S is also positive, delta G is also positive when it is non-spontaneous reaction at low temperature, non-spontaneous reaction at low temperature. Then fifth one is delta H is positive, delta S is also positive, then delta G is negative. It is spontaneous reaction at high temperature, spontaneous reaction at high temperature. Very important, बहुत important है guys. Last is 6 is delta H is positive, delta S is negative, then delta G is positive when non-spontaneous reaction at all temperature, non-spontaneous reaction at all temperature. Okay, yes sir. Okay, fine. This is the thing guys. Okay, delta, this is delta H, delta S they will give, we have to find the delta G and then we have to find the process. Okay, so this table is very important. भैया snap का time है, snap ले लेते हैं भैया. Very important ये, snap ले लेते, snap. चलो चला गया. Okay, ठीक है. Now we'll enter into the third law of thermodynamics. Third law of thermodynamics. Third law of thermodynamics. Third law of thermodynamics. Okay. Third law of thermodynamics. Understand one thing. What we know. Entropy. Only entropy is directly proportional to temperature. But if I will write change in entropy means it is inversely proportional to temperature. Okay. Yes, sir. We already studied, sir. ठीक है. So third law of thermodynamics, what it did say that according to this law, as temperature decreases, the entropy decreases, and at 0 Kelvin the entropy is minimum. Okay, minimum. Okay, understand one thing, we already know this, right? We already know that only entropy is directly proportional to temperature, but change in entropy is jaldi bolo bhaiya, yes, inversely proportional to temperature. So according to third law of thermodynamics, what will happen? As temperature decreases, entropy decreases, and at 0 Kelvin, what will happen? The entropy is at minimum. Minimum means 0 for a perfect crystal. It will be a perfect crystal. Okay. Sometime in the examination they will ask, at 0 Kelvin what is entropy? At 0 Kelvin entropy, we will not write that at 0 Kelvin entropy is 0. At 0 Kelvin entropy is minimum. Minimum means when 0 for perfect crystal, it is for perfect crystal. Okay. Now at absolute zero means 0 Kelvin, the system has no thermal energy and its particles are in their lowest possible energy state, means that is called as ground state. Okay, the system is in perfect order with no randomness or disorder, right? This easily we know. The absolute zero means 0 Kelvin. 0 Kelvin, what is happening? The system has no thermal energy, right? And its particles are in lowest possible energy state, means lowest possible energy state is ground state. So randomness is in perfect order, that is called as with no randomness or disorder. Practical evidence have shown that entropy of solution and super cooled liquid is not 0 at 0 Kelvin. भैया नाम याद रख लेना, ठीक है? What, like practical evidence has shown that entropy of solution and super cooled liquid is not 0 at 0 Kelvin. Exam may they can ask. Till now they have not asked, but maybe. After this, what we will write, guys? We know at equilibrium what will happen. We know at equilibrium delta G is equals to 0. At equilibrium everything is 0. Okay. So delta G is 0 means equilibrium what will happen? Equilibrium, it indicates that system has reached a point where free energy is minimized and no further spontaneous change process. Okay, so delta G is equal to 0 matlab equilibrium. Equilibrium matlab bhaiya spontaneous process, nothing will happen. Okay, so energy and all, it will be at minimum point. It will get minimized. Okay. Okay, we will write one relation. यहाँ पर अब relation लिख देंगे guys. After this we will write this. चलो भैया, this is relationship between, it's not your relationship. गजब उड़ा दिया सर, गर्दा उड़ा दिया. Relationship between delta G means gives free energy, and Q is what you can write in the bracket, reaction quotient. So relationship between delta G is a gives free energy and delta G is a gives free energy and Q is the reaction quotient. Okay, reaction quotient. So delta G gives free energy is equal to delta G naught. Guys, naught indicates standard, so the standard gives free energy, plus RT ln Q. Ln means natural log Q. Okay, this is a relationship. If they will ask in the examination, you have to tick that relationship. Okay, ठीक है sir. Now guys, we have to see some condition on this relationship. So see what will happen at equilibrium. At equilibrium what will happen? At equilibrium we know delta G is equals to 0. At equilibrium delta G is equals to 0. So what will happen? Then then delta G naught is equals to minus RT ln K. Ln K. Now you can ask, sir, why we are writing K? Because at equilibrium what will happen? Reaction quotient will become K. K means equilibrium constant. Reaction quotient will become equilibrium constant. So we know relationship between Gibbs free energy and reaction quotient is delta G is equals to delta G naught plus RT ln Q. RT ln Q. Okay, so at equilibrium, if you will see about equilibrium, at equilibrium what will happen? Delta G is 0. At equilibrium this delta G is 0. So at equilibrium delta G is 0 means what will happen? Delta G naught, what, how we will find the delta G naught? We'll send this to that side, right? So this is plus RT ln Q, it will go that side to become minus RT ln Q. But at equilibrium reaction quotient is equals to K. K means equilibrium constant. Okay, K means equilibrium constant. Okay, if you know guys, I can do like this also. Chalo bhaiya. See, at equilibrium what will happen? Delta G is 0. Delta G is 0. This is 0 is equals to delta G naught plus RT ln Q. So this RT will go that side, plus it will become minus. So what will happen? Delta G naught equals minus RT ln Q. But at equilibrium reaction quotient will become Q. Q means equilibrium constant. At equilibrium we'll talk about equilibrium constant. So at equilibrium what will happen? It will equals to equilibrium constant. At equilibrium it will equals to equilibrium constant. So that's why delta G naught is equals to minus RT ln K. At equilibrium constant we will write this. Delta G naught is equals to minus RT ln K. Guys, see this thing we can, if we want to remove this ln, what will come? I will show you. Delta G is equals to minus will remain as it is. If we want to remove ln, natural log, so in place of natural log we will get 2.303 log. Okay, in place of natural log, if we want to remove this ln, natural log, so this formula is this, ln equals 2.303 log. So how it will become? If you want to write this, okay, for the numerical we will use this one. For the numerical guys, we will use this one. So what will happen? Delta G naught equals minus will be as it is, it will become like this, 2.303 RT log K. Okay, and this we will use for the numerical because natural ln is not possible. So in place of that we will use this. Delta G naught is equals to, both we have a equation. So if we will remove the ln, we will get in log form. Log form is this, minus 2.303 RT log K. Okay. Now we will write down the few conditions and that's done. So see here, if K means equilibrium constant is greater than 0, means what will happen? So equilibrium favor, so equilibrium constant means K is greater than 0. So what will happen? Equilibrium favors, K is greater than 0 means it is moving in forward direction. So K favors the formation of product. Okay. So guys, see, they can write if K is greater than 1, or they can write if K is positive. So they can write if K is greater than 1, okay, or they can write if K is positive. So what will happen? It indicates that forward reaction. Okay, so they can write if K is greater than 1. If K is greater than 1 means what? K is positive, means what? It is going in forward direction. Forward direction means equilibrium favors the formation of product, because forward direction where we are reaching, from reactant we are reaching to product, If K is greater than 1 means K is positive. Means it favors the forward direction. Forward direction favor means equilibrium favors the formation of product. So what will happen? Delta G naught. Guys, see, I'm writing delta G naught. I'm not writing delta G. Delta G means Gibbs free energy. Delta G naught means standard Gibbs free energy. The standard Gibbs free energy is less than 0, or standard Gibbs free energy is negative. Okay. Now second point, if K is less than 1. If K is less than 1. K is less than 1 means what? If K is negative. K is negative means it will go backward direction. Backward direction means from product to reactant. It will move in backward reaction. Forward reaction, backward reaction, or forward direction, backward direction. So here what will happen if K is greater than 1? Equilibrium favor the formation of product. So delta G naught is less than 0. Means delta G naught is negative. So K is less than 1. K is less than 1 means negative में जाएंगे. So no. K is less than, अच्छा K में नहीं लिखेंगे, लिख सकते हैं less than. हाँ, less than 1 और नेगेटिव भी लिखता है भाई, दोनों लिख सकते हैं. K is less than 1 और नेगेटिव. दिस इज हाइपोथेटिकल नेगेटिव के लिए. दिस इज हाइपोथेटिकल. तो बैकवर्ड मीन्स व्हाट विल हैपन? बैकवर्ड मीन्स equilibrium. Backward means equilibrium favors. Backward means equilibrium favors the formation. Equilibrium favors the reactants. Equilibrium favors the reactant. Okay, what will happen here? Equilibrium favors the reactant because going in backward direction. So if equilibrium favors the reactant means delta G naught is greater than 0. Delta G naught is greater than 0 means delta G naught will have positive values. Delta G naught is greater than 0 means delta G naught is having positive values. And last is what? If K is equals to 1. If K is equals to 1 means delta G naught is equals to 0. K is equals to 1 means delta G naught is equals to 0 means what will happen? Here we will say at equilibrium. At equilibrium. Fine. So this is the done for the क्या भैया? Okay. We will write one note. After that this thermodynamics will get over. ठीक है, thermodynamics will get over. From now onwards we'll start for what? जल्दी बोलो. Yes, chapter number 3. So I see here. Note just write on this. Born-Haber cycle is an application of, in examination they can ask, Born-Haber cycle is an application of, जल्दी बोलो भैया, which application? Born-Haber cycle is an application of his law. So Born-Haber cycle is an application of his law. Second is BHC. I will write. Don't write BHC. You have to write Born-Haber cycle. Born-Haber cycle is used mainly. Born-Haber cycle is used mainly to determine. Born-Haber cycle is used mainly to determine lattice enthalpy. भैया this all point is very important. उड़ा के पूछ देगा. Is used to determine lattice enthalpy. Okay, so lattice enthalpy we cannot able to measure directly, so that's why we will use the Born-Haber cycle. BHC means Born-Haber cycle to determine the lattice enthalpy. So first we get to know Born-Haber cycle is an application of Hess law. Second we get to know Born-Haber cycle is used mainly to determine lattice enthalpy. And okay, this is also important. Lattice enthalpy represents what it will represent. Lattice enthalpy represent the strength of ionic compound. Lattice enthalpy is what? Lattice enthalpy represent the strength of ionic compound. बहुत important है भाई. Lattice enthalpy represent the strength of ionic compound, not the covalent or metallic compound. It represents the strength of ionic compound, which means what does this mean? If I will say, this means that higher lattice enthalpy, higher lattice enthalpy, strength means what? जल्दी जल्दी बोलो भैया. Strength means stability, stable. तो this means, चलो लिख देते हैं भैया, higher. This means what? Higher lattice enthalpy means a strength means more stable ionic compound, Okay, this is done. Now you can say like this also, guys. Increase in the lattice energy, increase in the strength of ionic compound, or more lattice energy, more is the strength of ionic compound, or higher is the lattice energy, higher is the strength of ionic compound. Strength means what? Stability. Or you can write like this also, higher lattice enthalpy is the higher stability of ionic compound, or more stable ionic compound. So these are the, like, if you know the concept, you can easily able to write these things by shuffling the statements. So this is done, guys. In the next video, like one video I will upload, in which I will upload all the exercise questions, like 22 exercise questions of NCERT exercise. I will explain and I will upload. Okay, so in like from next video onwards, I am going to upload for chapter number 3. And where you will get, guys, come to my channel, go to the playlist. Don't simply randomly search on the video. Come to my channel, go to playlist. In playlist you will see the name of the chapter. So for this you will see the name of the chapter, thermodynamics. To click the thermodynamics, you will get video 1, video 3, 4, 5, 6, like that. So for next chapter, you search the name, right? Classification elements, like that, of periodic properties. So search that, you will get that chapter. So according to chapter, you have to come to my channel, go to the playlist and search for the chapters. Okay, guys, thank you. Bye bye. We'll meet in the next video with a new chapter, and we'll enter into the inorganic chemistry. Oh, bye bye. Take care.